For centuries, historians and archaeologists have asked one of the most transformative questions in human history. Where did farming begin? And who were the first people to make the dramatic shift from hunting and gathering to growing crops and settling in villages? Recent breakthroughs in ancient DNA research are beginning to answer that question with clarity and complexity, revealing a story that spans continents and millennia. Ancient DNA extracted from the bones of people who lived between roughly 12,000 and 8,000 years ago shows that the earliest farmers were not a single uniform group, but rather several genetically distinct populations emerging across the Fertile Crescent in the Near East, a region that includes parts of modern-day Turkey, Iran, Israel, and Jordan, each of whom played a role in humanity's agricultural revolution. According to studies published in scientific journals such as Nature and reported by major research institutions, large-scale genome analyses of remains from this period demonstrate that these early farming groups were genetically different from one another, and in some cases descended from local hunter-gatherer populations who adopted farming independently, while others reflect deeper ancestral lineages that predate the Neolithic transition. In the Near East, teams led by geneticists at institutions like Harvard Medical School found three major farming populations whose genomes reveal a patchwork of ancestry. These farmers in the Levant, Anatolia, today's Turkey, and the Zagros Mountains of Iran show unique genetic signatures, but each also shares connections with earlier hunter-gatherer groups in their respective regions, suggesting that the adoption of agriculture was not simply the result of one people displacing another, but rather a mix of innovation and cultural exchange. Once farming began in these heartlands of early agriculture roughly 11,000 years ago, people and their crops began to move. Ancient DNA research shows that some of the first farmers migrated into southeastern and central Europe, bringing domesticated plants and animals with them and mixing with indigenous hunter-gatherers there, reshaping the genetic landscape of the continent. Meanwhile, groups related to Levantine farmers moved south into East Africa, and others related to Iranian populations moved northward into the Eurasian steppe and eastward into South Asia, contributing to the diverse genetic heritage of many modern populations. These findings overturn earlier simplistic models of farming spread and highlight the complex web of human interactions that underpinned one of the greatest transitions in our story. Rather than a single origin point, the dawn of agriculture involved multiple communities experimenting with sedentary life, domesticating plants and animals in parallel, and sharing knowledge across wide regions. The genetic trace left in ancient genomes helps us follow those paths of movement and contact, illuminating how farming and the settled societies that followed reshaped human history. And that's something worth remembering when you next think about where our food, and perhaps much of civilization itself, truly began.